Hi guys, good afternoon. Let me conduct a poll on my voice clarity. Is it good? Is my voice is clear? Yeah. Just now I have published a poll. Ye- Most of you say around 85% of you say yes. Muhammad say it's too slow. Is it guys? Too slow means my voice is low. 75% of Nickel says no. It's clear. Maybe system volume. Let me check my system volume. Okay, done. Now guys, let me share my screen now. Nothing is yet visible. I'm sharing my screen. Yes, my screen is visible, right guys? Now, can you see my screen? Let me publish a poll. Yep. Is my screen visible? No, I have shared it. So you would be seeing my browser now. Let me open the presentation. Now guys, is my screen visible? You will see my presentation with the name Internet of Things. No. Why is it so? No, no. I've shared my screen. You would be able to see. Just give me 2 minutes, guys.
Srija ma'am,
Yeah.
so your whiteboard was on,
Yes,
for
Manidhar.
which, yeah, so your whiteboard was on, for
Okay.
which the screen was not getting shared. I have turned off the whiteboard for you, and now I think people can see your screen, but it's a bit blurry actually.
Okay, then I will use another laptop. No problem.
Yeah, sure. So, friends, please have some patience. She's trying with another system to solve out this issue. Till that time, just give us 2 more minutes and we will be starting the session. All right, guys. Thank you for the patience, guys.
Just hold on 2 minutes, guys. I'm joining with a different system.
Meanwhile, she switches to another system. Let me answer a few of the questions I can see you guys are putting up. So, Mr. Ujjwal, so making notes is completely your choice. We will share a replay link with you, which will be our YouTube link for which you need to subscribe in our YouTube channel, and you shall get the access to our videos. But notes is up to absolutely up to you, Ujjwal. If you think you should take the notes, you can take the notes. No worries about it. But yeah, video you will definitely get it from us. Then I can see. Well, Vanita, if you can hear me, I'm not sure if you're able to hear me. I think I should drop you a message for you as well. So it shows broadcast will start shortly, right? So in that case, you need to refresh and click on the start broadcast icon. There will be a play button. You need to click on that and start with the session. Then only you can see that. For all the people who are saying screen not clear or display is not visible, so our facilitator Srija, she is checking with another system just to solve out this issue. Just give us 2 more minutes and everything will be sorted out. uh, Going forward, I can see the session is already started, guys. You can just log in, it's already live. We are just fixing out some technical things so that it becomes seamless for all of us. All right. Mm, I think I have answered a bit of the major questions you guys are putting up. All right, so all of your questions will be answered. Just a request: if you are unable to hear the voice, or if you're unable to see the screen at any point of time, before dropping a message, please refresh your link, because it often happens that it is due to network issue, and just putting on a message might result into something. Some people might have some genuine questions related to the topics, and we might miss out on that due to the load of messages coming around. So voice not clear, then screen not visible. It is now, yeah, it is going on now. I understand, and it will be fixed. But once it is fixed, please try to refresh your browser before coming back to the chat room. because that will help all of us to address some of the technical questions or some of the genuine subject questions. Okay. um, what will be taught actually, Gayatri? So Gayatri, this session is regarding IoT, which is Internet of Things. You will know what is IoT and a bit more detailed way. Join, no, continue with the session and you will get more clarity on this. Okay, and yeah, Naresh, YouTube link we will surely share. Just continue with the session and you will see the YouTube link in the sticky messages. I think Srija is all set with her session, with her presentation slides and all everything. So let's get started, guys. Just be connected and enjoy the session. Srija, it's all about starting of the session. It's over
Yes,
to you. Thank you.
yes, yes. Thank you. Thank you, Manidip.
No problem.
Okay. Hello, everyone. Good afternoon. Thanks for waiting. My name is Srija Depuru. I'm your facilitator for this course, Internet of Things. So we will see what is this Internet of Things, why Internet of Things, what is a big deal about it, and this course is of 24 hours daily. We will be having 2 hours in weekdays. So in this 24 hours duration we will talk about IoT devices and how they generate data and what you will do with the data. So using a cloud platform, IBM Watson, we will explore this Internet of Things. Okay, guys. Hope my video and audio is clear. Let me conduct a poll so that I would know. Yeah. So I have posted one poll. Yes. 100% yes. Excellent. So we can start off. First, we will see what is this IoT, Internet of Things. Some of you or many of you might have heard this, and you might have been reading articles or seeing some videos. They say that using Internet of Things, using connected devices, using connected things, this has been achieved. Say connected home, connected cars, a smart retail shop, smart watches, everything has become smart now, right? uh, the tag smartness has been added to everything. So I have wondered when I'm going through this one article. So even smart diapers are available. That means when diaper is full, you'll get alert to your phone. See, smartness has been everywhere and in everything. So that is happening with Internet of Things. Let us discuss what is this. Uh, a simple definition of Internet of Things. We will start with that. Internet and things. There are two words here in IoT. Internet of Things. So Internet, we know about it. We have been using it for a while for various things, for chatting, for file retrieving, social networking, online shopping. So today, world will get stuck if there is no internet. So if there is no internet, say for a day, everything will be stopped. So deliveries, work, etc., etc. So this internet has brought people around the world. It connected people around the world. So we anywhere in the world we are able to communicate, talk to each other, do work together with the help of this internet, right? And experts have named this internet as Web 2.0. So why they have added this Web 2.0 or 2.0? Because there is a Web 3 available. So it's a new version, that is Internet of Things. So this internet is now connecting things. So the internet so far we have used to uh, connect with each other. It's connecting people. Now this internet is also connecting things. That's why the name is Internet of Things. When you expand capability of internet from connecting computers globally to connecting several small electronic devices, Internet of Things is formed, right? So that's a pretty simple definition. Connecting things is all what IoT do, and how it does, why it does. So to answer these questions and also to implement a solution for these questions, there are lot of IoT protocols has been discovered, or and a lot of hardware devices are manufactured. Let us talk about them also. Let us start with the definition. This is a simple definition of Internet of Things. And let us know what IoT do with these use cases or examples. What IoT do to your traffic management system or your cars. So connected cars has become a buzzword in recent days with the evolution of this IoT. So telecom operators, automobile manufacturers. So someone, if they are dealing with in these sectors, especially, they know about this connected cars. Connected cars means one car is connected with other car. It can connect to other car, and also with the city's infrastructure like traffic lights and other things. And also car is connected with you. So car is connected with you, and it's with fellow car, and also with the roads or city's infrastructure. And why we have to do that? Car can know what is the speed of the car next to it. This car can know where it is traveling, what is the upcoming route, so that it can update you the upcoming fuel stations or restaurants. It can also guide you route based on weather. So if weather is foggy, it can guide you route according to that. And huge improvements are happening, especially in informatics area of car. Informatics means information and entertainment, to put together informatics. So our access to cars is going to be in a next level, um, maybe by next decade. So a lot of things is happening in connected cars. And this one, no need to introduce smart watches. You know what they do. They will tell you how many hours you have slept, what is your heartbeat, and how many calories are you burning, how many steps are you walking, so on and so on. And so these smart bands, a lot of industries, especially huge industries dealing with a very large scale, like mining, oil industries. So what they are doing is they are manufacturing these kinds of smart bands. So they won't tell you about steps count, calories and all. Instead, they will alert field engineers about what's happening on the field. So they will get overview of the entire field, which will be very huge. But they have a smart band, it will tell what is happening in the field. And similarly in healthcare, customized health bands and bands to track children, or any other things. If you want to track, if I want to track my kid, I am going to some a busy place. So these kind of smart bands are available. Just tie a band to his hand, you and download an app in your phone. You can track his location. The same way healthcare. Doctors can treat patients without actually visiting them because they have all the data on the cloud, their blood pressure, their diabetic levels, etc., etc. So the ease of treatment, this smart bands brings that. And this is another use case, smart farming. So what IoT has does to farming or agriculture, it has made it smart so that your field will tell you when to water and how much of pesticides has to be used, because it your field knows whether field is dry or not, is there is any bug, if so, where, in which part of the field. You will get all these updates from your field, right? That is smart farming. And also you can set up suitable environment for your crop. So some crops needs humid climate, some needs warm climate, some needs little bit cold climate. So based on that you can customize your environment. And this is a very interesting use case, connected cow. So data will be everywhere, and wherever data is there you can collect it. When you collect the data you can benefit out from the data. That's what a Japanese company did. They have used pedometers, the sensors, to count number of steps. They have counted number of steps a cow makes each day, and with that they would able to know whether cow is active or inactive, whether it's in heat stage, that means the stage when it is ready to mate. So by knowing all these things they can monitor their cow's health and increase their productivity. And this has started with a Japanese company, cattle industry. They have started with pedometers, experimented with that, and now lot of cattle industries across the world are implementing this, not only with pedometer, with other sensors also. They are manufacturing monitoring devices, tying it around cow's collar, sorry, neck. They would able to know whether cow sitting or standing position, how much of feed it's taking, its temperature, its step count, like this. So if one person sits in front of his computer and view his dashboard, he will come to know about thousands of cows. So that's what IoT does to ca- cattle industry. And what IoT does to factories, they can automate things. Not only automating things, they can monitor their machinery so that even if they break down, they will come to know and they will fix it. So that first thing is they can prevent losses, and second thing is they can increase their productivity, because knowing uh, about the machinery health, they will know when to take a break, like these things. And smart retail chain. So how many of you know about Amazon Go? It has been launched in 2017, at the end of 2017. How many of you heard about this? Cashierless stores, no checkouts, no lines, their tagline. How many of you heard about this? Oh, video not clear, can't view the screen clearly. hmm Let me check my internet connection. Yes. Okay, Omkar says Amazon store, Amazon Go. Yes. So how it works? So let me share my screen and play a video of that. Go to Amazon Go. So here it is. Yes, guys, that's what Internet of Things will do to your smart store. Let me share my presentation. Okay. Yes, that's what IoT will do to your normal cars. It will make smart and connected. To your normal watch, it will upgrade it to a smartwatch. A normal form can become a smart form, also called as greenhouse farming. Nowadays, they are calling with the name greenhouse farming. So that's what IoT will do. It will bring intelligence into the system, into the thing, into the device, or into the system, right? So, and how does Amazon Go works? Can anyone guess how it works? How they do know what you are picking up? Your voice is not there, is it? I see. Guys, am I audible? Census. Omkar says customers simply enter into the store using Amazon Go browse and partially automated. Yes, a lot of you say that my voice is clear. Maybe check your internet, maybe rejoin again. So how it works? Lots of sensors to know whether product is in the right place or not. Weight sensors and sensors to detect obstacles. They will detect whether the product is there or not. When there is no product, obstacle will not be there. So those kind of sensors, weight sensors, all these sensors, and lots of cameras in their roof which are monitoring you, along with these sensors in their racks, along with the help of AI algorithms, machine learning, and AI's intelligence. So the result is Amazon Go, store like Amazon Go. Okay. It is similar to RFID chips? No. RFID chips will just track, uh, used for tracking. They will tell you whether the product is there or not if there is a sticker on the product. But here they are using a lot of sensors to know. They have to update your cart if you pick up, or if you put it back, or if you put it back somewhere else also. They have to update it in your cart. Sorry. Okay, Internet of Things. It's what, of course, along with your artificial intelligence and machine learning. So, Internet of Things is the driving force behind this, all of this smart environments. If it is a connected car, or a connected cow, or a smart retail store, or a connected factory, so the concept driving them is IoT, Internet of Things, and there are different shades in this IoT, like consumers IoT, industry IoT, enterprise IoT, social IoT. Right? IoT is a generic term, and today a lot of things happening, lot of things are upgrading to smart things with this IoT evolution. And who has started this, who defined this concept, Internet of Things, is the one who is on my screen. Kevin Ashton, he is also called as father of IoT. He is the one who coined this term, Internet of Things. And there is an interesting story behind it, how he named it as Internet of Things. And later on, he has defined a definition, and that definition is becoming true nowadays. So, what he told is, before talking about what he told, let us see how he has coined the term IoT. He used to work in Procter and Gamble, which is a very big retail and supply chain in US. And some of you says no audio. Bharat said, Hussein said, guys, is my audio clear? Any disturbances, or it is not clear at all? Let me conduct a poll. Uh, yeah, most of you says it's clear, around 98%. Okay then. How he coined this term IoT, Internet of Things, is when he was working with Procter and Gamble, a company, supply and retail chain company in US. He noticed that when some product is not there, suppose one cosmetic product is not there in that section, particular section, cosmetic section, it's not immediately recognized and replaced. So to resolve this, he had come up with an idea of using RFID tags. Today we are extensively using them for tracking our products. Even small, very small shops are using this RFID tags now. That was the first time in 1990s. This Kevin Ashton uh, has proposed the idea of using RFID tags. And that time in 1990s, to explain this project of or concept of using RFID to track the product presence, he has to prepare a presentation to explain it to the higher officials. And he has named that presentation as Internet of Things. That's how he has coined the term. And later on, to the same journal, RFID journal, he has given definition of it. He told that If we had computers that knew everything there was to know about things, everything about a product or everything about a machine, everything about a room. So, using the data gathered without any help from us, we would be able to track and count everything and greatly reduce waste, loss, and cost. We would know when things needed replacing, repairing, or recalling, and whether they were fresh or past their best. And that's what we are doing now. It's already happening now. Things are telling you without they are gathering data, they are telling you what's happening around you or what's happening with the things itself. And with that data or information, we can greatly reduce waste, loss, and costs, and also things itself will tell you when you have to repair them, all these things. So this is the latest definition given by Cranberg in 2008. So this is a newest one, dynamic global internet network with self-configuring capability of devices. So it tells much details like mechanical and digital machines, objects, animals, people, and have unique identities, physical attributes, virtual personalities. So by this time, you know what IoT is. IoT is about making things smart, making systems smart, because a lot of such smart things will make a smart system. And moving on to next thing, that make internet working of things. So how do you make things smart? Right, they have to collect some information from their environment, they will sense their environment, they will process the data they have sensed from their environment, and they will communicate with other things or with a server which is called cloud. So we are internet working smart things. So that's why we call internet working of things or internet of things. So when I say internet of things, is internet is mandatory? Is it necessary for a IoT to have internet? What do you think, guys? Yes, Srihari also asked the same. Guys, is my screen visible to you all? Let me have a poll because yeah, just now I have posted a poll. You should see internet working of things slide on my screen. Yes. 100%, around 98% says yes. Excellent. We'll continue that. Yeah, I have asked a question. Is internet is necessary for IoT? Yes. Internet is necessary, but without internet also you can implement IoT. Because IoT is all about making devices smart, making things smart. And how you can achieve that is one part is connecting devices with each other, like your phone your watch is connected to your phone, same time your car is connected with your smart home, all the appliances inside your home are connected, right? But that connectivity is not necessarily a internet, it can be a Bluetooth or Zigbee, any other thing. Say for example, when I say smartphone, previously, say around 7 years, 6 to 7 years back, say for example 10 years back, the phones are not smartphones. Those phones, mobile phones, are just used to text messages, or for regular call. Right, today we are using lot of things with our smartphone. They are little computers. They are equivalent to your laptops and desktops. And how you are doing that? Through internet, of course. Every phone these days is connected to internet. And is smartness is in your phone or on internet? When I say smartphone, the smartphone using a lot of things and it is accessing them using internet. Is internet is smart? Phone is smart. Obviously, phone is smart. Yes, phone is smart. It is smart enough to use a technology called internet. So IoT main focus is internet, and in most of cases to communicate data with other things or server we use internet. But even though without internet, you can implement internet of things using like Bluetooth, Zigbee, other things. WhatsApp is an IoT product? No. Yeah, IoT can use your WhatsApp. Also, WhatsApp is an application. It's an app. It's an application. So, focus of IoT. Just now we have discussed. Focus of IoT is making our everyday things smart. Everyday things like thermostats, headsets, irrigation pumps, my home appliances, these things smart. So the main focus of IoT is configuration, control, and networking of things. So configuring things so that by embedding some electronics into them along with some sensors, they will become smart with your configuration. Control them. What to do now? They will collect data. What to do with the data? My smart device is collecting brightness in my room, brightness values in my room. What to do that? You have to control it. Based on that, it has to switch on or off the light. Control your things. Network your things using internet or Bluetooth or Zigbee, any communication, networking, so that they can communicate the data with other things or with the server which will be on the cloud. Right, that's what main focus of IoT, making things smart and connected. So there is a three dimension here. So ICT, or information and communication technology, it has two dimensions. Now the third dimension has came now. Previously with this ICT, we are saying that we can communicate anytime and any place. Now the third dimension is anything can communicate using computers. Previously computers are used to communicate anytime and at any place, and these days computers, small computers which will be inside the things, using them anything can communicate. And that makes your world connected. When you have smart things connected with each other, and then the system will become, suppose say my home is smart home, I have lot of appliances. They will communicate with my home and also communicate within themselves. In the same way, there are a lot of homes like that. My building is a smart building, and there are a lot of such buildings in my city. So your world will uh, become a connected and smart world, which will become a better world to live in. And by this time, you can answer this: where you can use IoT? Everywhere. Where data is there, there you can use IoT. Data is everywhere, you can use IoT everywhere. IoT is a ubiquitous thing, a technology that can help all other domains. The domain which can help all these domains is IoT, Internet of Things. Bluetooth Wi-Fi communication can be an IoT. Alexa is a product of IoT. I told Internet of Things, right? Things have to be connected with each other. So that connectivity can be Wi-Fi or Bluetooth. And Alexa is a product of IoT. If you are using Alexa in your IoT, then it becomes the thing in your IoT system. Using Alexa voice control, you are switching off your light or fan or opening doors, say for example. So it is also one thing in your IoT system. So you can use these things, Bluetooth, Alexa, and IoT. Yes. Connected car is not IoT product. Yes, it is. When I say IoT, IoT is all about generating data. That's what we have discussed here. Where it here. So main focus of IoT is configuring the things, controlling the things, and networking the things. By doing so, you'll get data related to your room. If it is a connected car, data related to your car, right? So now what I need to do that, uh, I got GPS location of my car. I got the speed levels of my car. I got other things related to my car based on its fuel, engine, etc., etc. So this part is IoT. How you are getting all these things? How? This is IoT. How you have upgraded your car, and the second part of it. Now, what you do with data? So I have used lots of sensors, electronics, generated data. I know where my car is now, fuel levels, everything. But why? So the answer for that, your data analytics, machine learning, or AI, these will give you. They will make use of the data and come up with some cool applications. And so to transport this data from one place to another place, car will be on the road, you will be in your office, but you will be looking at dashboard, you know where the car is, what it's doing, all these things. How it happens? Connectivity. Sometimes it is Wi-Fi or cellular, internet. Sometimes if it is my home and connected home, I will use Bluetooth or Zigbee because I have no need to connect to internet. When appliances all are within the premises, I can connect them with Bluetooth. So main focus of IoT configuration, control, and networking the things that will make things smart and also connected. So you can visualize them. You can do simple analytics, which is a part of IoT, but for complex analytics, you need a data scientist and who deploys machine learning, all these things. Data analysis, for you'll collect data with IoT. Of course you can automate it based on the data. You can remotely monitor something. You can do simple analytics with that, but for complex things you need assistance of data analyst or data scientist. An IoT data scientist is a job role also who deals with IoT data. Okay, coming to data. Anyway, we are discussing about data. What is data? So we will be using this data term, and it's not a new thing for us. So what actually data is in terms of IoT, Internet of Things, right? So by this time we know what is IoT. I mean, what it does, it collects data from the smart things. And what is the data? How can you define the data? here. Collection of information. Okay, in terms of IoT sensor readings, yes, sensor readings are data, correct, but yes, sensor readings are will be data, of course, but how can you define that? How IoT helps in meter for electricity billing? uh, yeah, we will discuss that when we discussing about IoT connectivity. So smart meter, these things. So data is raw information, yes. Set of points which allows person to take decisions. Yeah. Internet of things. In this world of Internet of things, what is data? So let us see what are things in Internet of things. It can be anything like your home or a device inside your home which has some sensors and which collect some data and communicate it. Collect some sensor readings and communicate it. That is your thing, Internet of Things. So, what actually data in this IoT perspective is? So, objects will have some properties. Say, for example, if it is your, we will take an example of what is there here uh, in this picture. So, let us take example of my room. My room has attributes, properties. So, these properties are also called as attributes. So, what are my room's attributes or your room's attributes? So, what is your room's attributes? Height, length, width, temperature of my room. So, there will be a lot of physical things like that which can be measured. Those are properties. So, if I say shirt, so what is attributes? Yes, dimensions, how many people are living in, the temperature of the room, brightness of the room, all these uh, things are the properties of your room. And AC's lights or no, might be sometimes you can also call them as properties of your room. Features, yes. So when I say shirt, what is the properties your shirt has? Attributes of your shirt. So color, material, size of the shirt. So there will be a list of attributes for each object. Whatever might be the object, small or big, it will have attributes. And the data associated with those attributes, we call it as uh, the values associated with that attributes is our data and the IoT perspective. Say, for example, my room, the length, the breadth values, the brightness values, all these values put together, it's a data. For my shirt, say yellow is the color of my shirt, and the size is some XL, material is cotton, all these values. This set of values is the data. That is data. Values associated with the attributes. So I am telling this definition of data is in IoT perspective, because in IoT we will be dealing with things and their attributes. So values associated with the attributes is our data. So how it works? Why? What IoT does? So we have discussed what IoT will do to other systems like cars, agriculture. We have discussed. So there is something called as knowledge discovery process. So let me skip this. I will come back to this, and it's called as DIKW pyramid. data, information, knowledge, and wisdom. So data, we know what is data now, and that has to be converted into information. Say for example, my car, it is collecting data and it looks like this. And now it is converted into information, that is which is more meaningful. It says south facing traffic light on corner of Pitt and George streets has turned red. So who is capturing this data? Say for example, it's me. It's not a computer or something else. This data is captured by me. Forget about these things. How? By using my eyes, ears, I have captured the data, the location, the surroundings of the car or surroundings of me, and I will define a information like what is this area, what is my happening around in my environment. From that I will get a knowledge. Okay, um the traffic light in this road has turned red, so based on that I will stop my car. So this is DIKW pyramid. So now we are using computers to acquire data, not in car in many places, and convert it into information. Based on that information, you are understanding that information, and wisdom is nothing but decision making. You will decide what to do. I have to stop the car means I have to apply the brake. That is my decision making here. Wisdom means. So now with IoT, we are trying to automate these two things, knowledge and wisdom. Right, guys? So computers will collect data through sensors. They will convert it into information into readable format. You look at it and you will take decision. And now we are trying to automate these two things also. That means your car itself should know about its surroundings. Based on that, it should decide what it has to do. I better stop the car. Your car will make that decision, and the result is smart car, right? So that's what IoT is doing. In the previous example, also, this say for example, it's a factory. You will collect raw data from it, various things related to machinery, temperature, vibration levels of the machinery, uh, pictures of data coming from conveyor belts, lot of things, and they are stored in data warehouses. They are selected and transformed, and the result is you'll understand the data and you'll come up with a solution. Okay, guys. Hope things are clear. Any doubts? Any doubts to the topics which we have discussed so far? Harminder Singh, yes, it's a artificial intelligence. How to uh, take a decision. So if it's a simple thing like switching on or off the light, you don't need artificial intelligence actually. If it is something complex, like stopping a car or something else, if you are dealing with business intelligence tools and technologies, then definitely artificial intelligence, like the store, right? There definitely it's a complex one. Your IoT should be assisted with AI or ML, machine learning. Okay, let's take a break of 10 minutes. 2:55 is time in my place. We will start at around, again, we will connect at 3:05. So, meanwhile, let me see, is Enoch is there?
Srijal Enoch has not yet joined. He will be joining in the next 10 to 15 minutes.
Okay, no problem. Let's have 10 minutes of break. Yeah.
Sure.
Okay. Yes, guys, we have finished our break. Welcome back. Before continuing our session, I will hand it over to Enoch. He will demonstrate you about YouTube, our YouTube channel, and other things.
All right.
Yes, Enoch, over to you.
Thank you, Srija. So before I go, guys, let me see if how many of you are active, how many of you are sleepy. I guess all of you, it's your lunchtime. So let's just see how many of you can. Let's see. Just check your chat, and there should be a poll. So have a look. Hmm. All of you can hear me. 6% can't hear me, but they have answered the poll. All right. Most of you can hear me. So if you cannot hear me, then probably just simply refresh and it should go back to normal. Now, let me ask another question. How many of you had once? Let's see how many of what would you answer for this. Oh my god. Almost 80% of you had heavy lunch, huh? All right, that was just on a jovial note, guys. So, what I'm going to do is I'm going to show you how you can watch the replay of this, whatever session that's happening, and you can even watch the session live. So, I'm simply going to explain all of it. So, let me share my screen. And now you should see the tiles. So the very first thing that I'm going to do is I'm going to share where you can access this recording. So you see this YouTube link, this YouTube playlist, it says free IoT sessions. All the sessions that are happening will be in this particular playlist. So let me copy the playlist and let me share that with you guys. So the playlist is in the chat. And hi Prasanna, welcome from Singapore. Oh, my bad, guys. My bad. So let me put the link on the sticky note as well. And what I would like you guys to do is just click on the link. And if you have not already subscribed to us, I would recommend you guys and I would request you guys to please subscribe. So for you, it would look something like this, wherein you have the button which says subscribe. So please go ahead and click the subscribe button and subscribe to us, because this playlist that you're getting access to is a private playlist and not everyone will have access to it. Only you guys will have access to it because you are attending this session. And so I would recommend all of you guys to please subscribe. So is it clear? Let me ask you guys a question. Let me see how many of you have subscribed it. Have you subscribed to our channel? Let me put it YouTube channel. Yes or no? Let me know, guys. All right. Almost all of you have subscribed. For those of you who have not yet subscribed, what I'm going to do is just for you guys. I think some of you guys are still struggling for the link. So there you go, guys. That's the link, and it's also there in the sticky note on the top. Thank you, Vijay. Thanks. Thank you, guys. Thank you for subscribing. And Catherine, click on the link that is on the sticky note, this link where I'm highlighting it. So click on that, and that would take you to a page that looks something like this. And for you, you may see a button right here which says subscribe. So what I would like you to do is click on that button, and then that's all. Just click on the button, subscribe to us, and whenever we have new training like this, and tomorrow when we have the next session, you will directly get the notification without us contacting you. All right, that's one. And now the other thing that I would like you guys to do is follow us on LinkedIn and Facebook. So why do we want you? Uh, I think it is audible for most of the people, Ishan. So please refresh your meeting. So guys, the second thing that I would like you guys to do is just follow us on Facebook page. The reason we want you guys to follow you is like and follow us is all the programs that we have, they the information about those programs and the registration and the sign up forms are available on our Facebook. So this is our Facebook page. Okay, you can see it says 360 digit mg India, and you could see this our partnership with IBM poster is up on the top. So you can see, yeah, so we keep posting good content. So we had a quiz this morning, so we put a quiz here. So we generally post a lot of content here. So for that reason, I would recommend all of you guys to subscribe to this. Oh, Hassan, I think that could be the delay with the network, so I'm not sure. And the other thing that I would like you to do is follow us on LinkedIn. I know many of you may say that, hey, I don't have LinkedIn, I don't have Facebook. So for people who are gonna use this, yes, Vigneshwar, that should be good enough. I mean, we are gonna keep teaching you even if you do not subscribe, but we would love if you could subscribe. So this is a LinkedIn page, guys. What I would like you to do is click on that. And when you click, you can come here and this is where it says follow. Just click on that follow button and then you can follow our updates. And coming to the certificate, guys, yes, you're going to get certificate. And the attendance, we are going to take it from the backend. So we are all pretty good with technology, right? So we can pull the attendance from the backend and we are going to use that to track how many of you have attended all the days or how many of you have attended just 1-2 days and just left. So we can look at all those data and we would be considering all that for our certificate. So just to give you a recap, I've given you 3 links. One is our YouTube channel, and one is our Facebook, and one is our LinkedIn. So I'm going to post all the 3 links on the sticky note right now so that you guys can follow us. No, Santosh, you don't have to. All right. Thank you, guys. Thank you so much. I'm going to be here so you guys can ask any questions if you have. We're going to, yes, it is participation certificate. And over to you, Srija.
Yes, thanks, Enoch. Let me share my presentation. Yep. Uh, Let me post a poll, acknowledgement from your side that you can see my presentation. Sorry. Yes, are you guys able to see my screen, guys? Uh, yes, excellent. 100% yes. Yeah, that is DIKW pyramid. We are collecting data, converting it into information, and from that you'll get knowledge, and from there you'll take your decision. So we are automating this so with IoT. Say, for example, data is my room's brightness, sensor values, raw sensor values, and that raw values will be converted into a measurement. So, like you convert some temperature into degree centigrade, 25 degrees centigrade. Your sensor may not directly give you that, so there will be small computers called microcontrollers which will do that. They will measure based on the voltage coming from the sensor. So like this, data is my brightness. It is converted into information, which is some value that can be in a readable format under in a matrix. Then your device itself will define its context. That means whether room is dull, bright, or dark, or bit dull, like this. It will define its context. So your car has defined about its surroundings. Now the device inside the room will know about the brightness. What is the brightness inside your room? And it will apply. So like car applies a brake, your device inside your room take a decision of switching on or offline. So for this thing, end to end, you can implement with IoT. But for complex things, like if you want to monitor gas leakage inside a factory, like something like smart cars, robots, complex robots, say for example robot performing a surgery, so in these cases you need assistance of analytics. So data is run and processed, information is filtered, categorized, uh, which can be readable, and knowledge is which is more structured, and you can act upon it. So IoT endpoint. So we know what IoT is now. We talked about DIKW pyramid, and what we can do in this DIKW pyramid. We are trying to automate the whole pyramid in some scenarios, maybe to some extent in complex scenarios. What characterizes IoT endpoint should have? So, a IoT endpoint is a physical object along with the sensors, electronics. When I say controller, means some electronics which is controlling the sensor data, reading the sensor data, controlling the actuator, and internet. So here instead of internet, it can be Bluetooth or Zigbee, but uh, if you want to communicate with the cloud, then definitely you need internet. So this characterizes an IoT endpoint. IoT endpoint is nothing but a physical object or any device which has electronics. Using that, they can read sensor data and control some action and communicate them to cloud or other devices using internet. That is IoT endpoint. So, and a lot of people ask, so what is difference between M2M and IoT, or SCADA and IoT? Because sensor technology and IoT, because we are not using any new thing here in IoT, Internet of Things. A lot of terms are there, embedded systems are there. Previously, even before this term IoT, embedded systems are already there, machine to machine communication is there. These things are already there and we are using them. And now what is a big deal with this IoT? Why it's a buzzword these days? Because it's an evolution of all these technologies. So there is nothing new in IoT, it's an upgradation of the present systems. Previously your M2M, they are used for by industries, they are point to point communications, and the hardware used by their those devices. Of course you can remotely monitor your machinery or devices, but there would be one human to do that. So, and the IoT is different one. So whatever might be your device, the device can be a car, a thermostat, or anything. A variety of devices, irrespective of their hardware and software, can be connected. How? Using a cloud platform. All the complexities, all their hardware and other protocols doesn't matter because they are connected using a platform called cloud. So IoT is upgradation of M2M. IoT is upgradation of technologies like SCADA. Okay, guys. So we have talked about IoT, and I'm skipping this anyway. Uh, thereof because we discussed a lot what an IoT system should have. Of course, dynamicity. Once you deploy your system, there should be zero configurations. Say, for example, surveillance camera. I'm making it a smart. Now, the smart surveillance camera, when there is a low brightness, when there is a dull or a dark day, then it has to uh, update. I mean, it has to adjust its configurations accordingly, right? Dynamicity, a unique identity. All these are some features of IoT system. Uh, yes, DIKW pyramid. What's this? Have I missed anything in the chat? It's little unclear about DIKW pyramid. Yes, that's what you're saying. So DIKW pyramid is nothing but it is a concept of how you will make use of data. Data is collected from the environment. So let us discuss it using the same car example again. Say for example, there are sensors inside my car. So all the sensors are giving this data. So these sensors also have microcontrollers. So Prasanna says, can you explain each of these characteristics with some examples? So like data, information, knowledge, and wisdom, right? Okay, what data means? See, data means values associated with attributes, right? What is objects will have attributes and values associated with that attributes is our data, right? So numbers in binary form are not for this. Tools for IoT function. Binary form, those all, yeah, as we move along, we will discuss about that also, how data is communicated. We will also discuss about that. So size is tools for IoT function. Yeah. Uh, guys, is everyone clear with this? This DIKW pyramid is clear. Let me uh, publish a poll. Publish. So is this is clear? Yes. Excellent. Around 96%, 97 now. Okay. Then, so this is related to a DIKW pyramid and is tools of IoT functions. Which one? This difference table is nothing but you can go through this difference table. Yes, is this one is clear? M2M versus IoT. M2M is another technology where missions will communicate with other missions, but using non-IP protocols. Non-IP means it's not internet. Other things like Modbus, CAN, Ethernet. So you can call this M2M as a subdomain of IoT now, because IoT in some scenarios also uses this Modbus, CAN, and Ethernet, right? Clear with this one. So desired characteristics of IoT system. So what, say for example, you are an IoT engineer, you developed one product. So what are the desired characteristics for that product? Right, say smart garage door. As it says, it's clear, and DIKW pyramid is okay. Suppose smart garage door. You have developed a smart garage door, and now what are desired features? I want to buy it. What I will look into? Forget about the functionality, uh, smartness, all these things. So what user will ask you is, yes, everything is okay. uh, if there is something maintenance, right, how I have to maintain it, that is his question, because he is a non-technical person. You know everything about your IoT system, IoT product. When you are selling it, your user, he is not as technically aware as you. Then what are the desired characteristics of your IoT system? Dynamicity. Say it has to be dynamic. I have given example of surveillance camera. If it is little bit dull, it has to increase its brightness. It has to be dynamic with the changes happening in the environment. Zero configurations. So user is expected to do zero configurations in the system, even though if there are any software changes, upgradations happening. Like if you buy a phone, you'll do any configurations after, you will software or hardware configurations, no, right? In the same way, your IoT system, the user is not expected to do any configuration. So in the back end you have to do it, like if you're using phone, you'll getting alerts, right, for upgradation, all these things like that. But user on his own is not expected to do anything. And a unique identity. Sometimes if I network is changed, especially in use case of car, I am driving, my car's GPS location will be updated on the cloud, on the Google Maps, its application. Say for example, its location will be changing. So based on that, it should connect to network, right? And also it should establish a unique identity for itself, so that internet can recognize it. So every device should have a unique identity when it's connecting to internet. And semantic interoperability. If you are manufacturing a product, it has to be uh, compatible with other products also. So that is semantic interoperability. Whatever the hardware you're using, whatever the software you're using, you have to go by standards. So if you go by standards, then your product will be compatible with other products also. There will be no interoperability issues, semantic interoperability issues. And while if you receive from other device, data from other device, so there should not be any semantic interoperability issues. So if you follow the standards defined, then you can achieve this. Guys, just give me a minute. Okay, sorry for that. And integration into the information network, right? It has to integrate into your information network. Say for example, a connected factory, already there are machineries, and all these machineries are connected with each other. Now a new device is coming into the factory, a new machinery with a new device, and it is little bit advanced one. Say machinery are using devices, some software with version 2. The new devices coming with version 3, but it has to integrate into the information network. So these are some desired characteristics of your IoT system. Yes, so each device in IoT, K. Shanti asks that will have a IP address. Yes, if it is using internet. If it is using Bluetooth, then it will have a MAC address. If it is using Zigbee, it will have a MAC address given by manufacturer, Bluetooth or Zigbee manufacturer. So each device will have a unique identity, whether it is a MAC address, if it is a Bluetooth network or a Zigbee network. If it is a internet, it will have a IP address. Okay, let me have a poll. So clear with this IoT system characteristics. So IoT system characteristics is nothing but, if you think in your customer's booths, in the customer point of view, after delivering the project or after selling your product. So your product should not stuck. If there is any configurational issues, it has to resolve it on its own, and it should adapt the dynamic environment conditions. So those are the two things, and it should have a unique identity. Of course, this happens at manufacturing itself. Something called TCP/IP stack. If you are joining the internet, so it should have a unique identity, and as interoperability. So it has to be compatible with other products also, and integration into the information network. There will be other devices, some are older than the device, some are new ones than the device. Suppose, say for example, same connected factory, all the machineries are connected using Bluetooth 4 version. A new machinery has come in, and it has a inbuilt Bluetooth. Through that, it will communicate the information like temperature, vibration of the machinery, and it is Bluetooth 5 now. So even though there should not be any issues, it has to integrate into the information network. Right, guys, since most of you said it's clear, around 90% of you, let's move on. Yeah, Preetham asks, integration into the information network means, yes. Information network means your network of devices or exchanging data or communicating data, right? If a new device comes in, it has to integrate into that information network, irrespective of hardware or software. Okay, and how to build a IoT solution. um, so Naveen says the screen went blur. Yes, my screen is clear, guys. Is it blurred or okay? Don't see any. Messages regarding it's fine. Okay, clear. Yes. So it's a four stage. How to build a solution? Okay, we understood IoT. How what is IoT and all. We had gone through its definition and how to build a IoT solution. So the answer for this is there will be lot of answers. Lot of answers how to build an IoT solution because each solution is unique. As a IoT solution for smart home is unique. A IoT solution for connected factory is unique, right? There is no hard and fast rule. But we are going to discuss about generic architecture, which is the most happening one, right? There can be only three layers sometimes, there can be five layers sometimes, but this is a generic one. There is no hard and fast rule this has to be architecture. But this is the most happening one. Uh, so when you're traveling in GPS, it has have to be a network connection. No, because you'll be using a SIM card when you say GPS. So your phone, like your phone has a data, it uses cellular for communication. In the same way, GPS along with your SIM card, it will also work in that way. Yes, we will talk about this IoT solutions architecture. Definitely, let us take an example of predictive maintenance of some machinery. Let me share my screen and show you one such machinery because I don't have that uh, image on my presentation. So, bucket wheel excavator. Eh, Excavator. I'm taking example. It can be implemented to any industrial machinery. So, how it looks like, this is how it looks like. It is used for excavating the earth's crust used in mining especially. It's a very huge machinery and also very expensive machinery. See, this is how it looks like. See here, there is a you can compare it with a regular size car and the machinery, right? So this is a machinery, bucket wheel excavator, and there are of different sizes also. Maybe this is the biggest vehicle in the world. Okay, it is used in mining, and also it's expensive and also not available. The availability rate is only 50%. That means there is a availability requirement. Say 10 such machinery are required. Only 5 are available. So it's also expensive. If it stops working, production will stop. That is another loss. So what to do now? So let us put some IoT sensors now. Where I will put IoT sensors? Let me make it big. Mhm. It's not the entire screen. Anyway, okay. See here. This part is excavating part, and say there is another part here. It will pick up the load, right, guys? And I have to ensure that this machinery should not damage due to overload or over workload or overweight. So to not to put a overload or a over workload on it, what I will do is I will make use of sensors at this place to measure strain or stress and also weight it's picking up. And I will put temperature sensors and vibration sensors somewhere in this part of the machinery. They will capture how much temperature is generated at that point and how much is it vibrating. Yes, guys. And let me go to my webinar jam, share my slide, or I will share it from here. That is my stage one. Stage one, I have used sensors. So, and here stage one and two will become one device, guys. A pen is not available. Why? Anyway, the stage one and stage two put together, it will make one device. So, not gateways, data acquisition systems and sensors and actuators put together, it will make one device. And that device, what it will do, in our bucket wheel excavator, there is a sensor for temperature, and there will be a small chip which will be reading the temperature. And same, the actuators, sorry, we will come back to this actuators later. Similarly, vibration sensor along with some small microcontroller, it will give you vibration values. Similarly, weight values, the strain, uh, based on the stress and see the weight it's picking up, you can calculate the strain. So those values, all these are generated because we have used sensors, and sensors along with small chips called microcontrollers. So they will give you readings now. And who will collect that readings? Stage 2, either a data acquisition system or a internet gateway or a gateway. You can call it as a gateway rather than internet gateway. Gateway or a data acquisition system, it will collect it. Why? Because you cannot have a computer there on the machinery. All you can do is you can put sensors on the machinery. Now all the data has to be collected, and what you will do is within the premises of the machinery, you will have one gateway which will collect all the sensor data. That is your stage 2. Because your sensor devices, sensor with along that microcontroller, it will be a small device, and you cannot expect it to communicate with cloud, right? It is a low profile device. It might be operating on batteries, and its processing power is not that high. All these are constraints. So gateway will collect all this information from that sensors, and it will communicate with the cloud. So we will talk about this part later. Now your gateway will communicate with the cloud where analytics happen. So when temperature is high, what has to be done? When vibration is high, what has to be done? It is okay or anything is critical. If it is critical, what has to be done? And user has to know about all these things from a remote location. So that dashboard will be there on the cloud where there will be visualizations like gauges, charts, where user or someone who is monitoring these things can view it and know about things happening with the machinery. Right, that's what happened in the cloud. Right, guys? Any doubts regarding this? Stage 1, stage 2, and stage 3. Yep. Screen not clear. Uh, so is IoT device is inbuilt. Sometimes if manufacturer is manufacturing smart machinery, that is inbuilt. Or If some factory guy, industry guy came to you, and now he have to make your machine, the existing machinery smart, then it is not inbuilt. You'll figure out some way to put it in. Yes, it is. Stage 1, stage 2 and 4 are clear, right? Let me share my slides presentation. Yes, stage 1 are sensor devices within the machinery. Our machinery is bucket wheel excavator. We are measuring temperature, vibration, strain, and load. That is weight picked up by machinery. Now, this sensor devices will communicate with a gateway, which is a more powerful computer than a small chips. Sometimes your phone is also gateway in some IoT systems, not in this scenario. Say in your smartwatch, right? In smartwatch, your phone is a gateway. Your smartwatch will send all the data collected to cloud. And how it does, it will not directly connect to cloud. Say Fitbit guys will have a cloud. After your week data, they will give you insights, improvements, these kind of things. So how data is going to cloud? It's not from your watch, it's from your phone. You will be downloading some app, right? From that app it will go. Vijay, screen not clear, can't see the alphabets clearly. Okay, it is a issue with webinar jam. I can't make it big also. So anyway, stage 1 is sensors, and stage 2 is our gateways, which collect data from the sensor devices. Stage 4 is cloud, where your machine learning and other analysis happens. You will visualize data on your cloud dashboard, uh, these things. And what is stage 3? Can anyone guess what can be stage 3? So this stage 3, you sometimes data engineering, it's called as edge analytics. So stage 3, sometimes your gateway has to make the decision without waiting from the cloud. Say recently gas leakage has happened in our nearer in our state. Say for some in some location gas leakage happened. uh, so if you want to avoid those conditions, or if you want to take some action without before damage happens, so same sensors, stage 1 will collect data, this time gas sensors, and stage 2 will update to cloud. And if is gas leakage detected, some gas is detected by the gas sensors, then cloud will immediately send response to shut down uh, something there where leakage is happening, some walls or some machinery there where actual leakage is happening. But if there is any network delay, bandwidth delay, or latency issues, then what happens? It will become disastrous, because every second is important in such scenarios. There you can implement analytics at your gateway itself, right? And after that you can share information to cloud for more deeper insights, for visualizations, all these things and all. You can use cloud when there is immediacy of response, and sometimes network is not always available, especially in oil and mining. There will be choppy network. In such scenarios, you can do analytics at your gateway itself. That is called edge IT or edge analytics. Clear, guys? Clear with the four-stage architecture? Is everything clear? Any doubts? Stage one is the sensors, where you acquire data. Because stage three is a software running on your gateway itself. Say, in my industry, I have all these sensors which are communicating with one device. That device is also capable of doing analytics, that is edge IT or edge computing. And stage 4 will be somewhere remote. We don't know where that server is, whether it's AWS or Azure cloud or Google cloud, but actual computer is, where is that one? Where is that server? We don't know. That's why we call it as a cloud. But this stage 3 analytics will happen on the computer in your premises. Why? Because you need immediate response in certain conditions, and also in some scenarios network is not always available, maybe. So that is your edge computing. Could you please explain stage 3 again? Yes. So what you'll do in stage 4, I mean cloud, all the data through gateways will go to cloud. What you will do there on cloud, say for example, the same gas leakage thing, in that use case, what you will do on cloud? Of course, you can build a visualization dashboard, and suppose gas leakage is detected, what your cloud will do? Yes, it will make analysis, right? It will make analysis and detect the gas leakage. And the same thing will happen in gateway itself. That stage is called a stage 3, right? uh, Storage, yes, you can store data, you can analyze data, you can visualize data, you can build a web page. A lot of things can be done on cloud, but some part of that analysis can be deployed on your gateway itself. So this gateway is an intermediary device between your sensor devices and cloud. Sometimes you can deploy analytics in the on the gateway part itself. That is your stage 3. So whatever you're doing on the cloud, which are necessary, I mean immediate things, when has to be done, like immediately shutting down the machinery, or immediately turning off the valve where leakage is happening, that kind of analytics can be deployed on your gateway itself. That is your stage 3, edge analytics or edge IT. Analytics is happening on your premises, not on the cloud, on a gateway device. So later on, for more insights, you can share that information to cloud. Right, guys? Clear with the 4 stages? Any doubts? Let me publish a poll. Clear with IoT architecture. See, you can correlate this IoT solutions architecture with any IoT solution you know. Smartwatch, most of us know it. So stage 1 is your sensors inside your smartwatch. Um, Biochemical sensors, heartbeat sensors, all these things, accelerometers, gyroscopes to know your positions, these things. What is a gateway here, guys? How all these sensors are inside in your watch? Yes, your smartwatch is a device which has all these sensors. That is your stage 1. What will be your stage 2? Let me check it. What will be the stage 2 in our smartwatch? No need of attendance, Ishan and others asked. I think no need of attendance. It will be tracked in the backend. So we are discussing about smartwatch, right? What is a gateway in our smartwatch application? Yes, phone, right? When you open your app, Fitbit app, say for example, it is a Fitbit watch. Fitbit app is running on your phone. When you open your app, your watch and app will become in sync with each other, and your watch will send all the data it has collected to your app. Your app will send to cloud. So here there is no stage 3 happening. Analytics is not happening on your phone, so it's happening on cloud. And sometimes analytics happens on gateway devices. So that is our stage 3. And what are the microcontrollers used in IoT? There are lots of them. We will discuss that. They will also comes under stage 1. Some of them in can be used as gateways also. And how we use them, that's our tomorrow's class. Can you please give us link of the presentation? I am not sure whether presentation will be available or not, since it's a free program. Okay then guys, hope you all enjoyed the session. See you tomorrow at the same time. Yes, can we use Arduino for prototyping? We have some hands-on on using Arduino in our tomorrow's class. Use case for stage 3, gas leakage monitoring, uh, and these kind of things. Some analytics will happen. Instead of phone, assume another device which is collecting sensor data now. That device also have a machine learning algorithm. That algorithm will detect the gas leakage based on the real time values. It's not sending all the values to cloud and waiting response from the cloud. So some analytics is happening on your gateway. Machine learning algorithm is running on your gateway itself, that device itself. That is your stage 3. Okay. Okay guys, hope you all enjoyed the session. See you tomorrow. Yep. Bye bye. If your video available, yes, if you subscribe, I think link will be available. Yes. Thank you guys. Bye. And end the session.